So guys, going forward, now let us discuss the steps regarding how ARP protocol actually works. So here the problem statement is that how the sending machine, that is the machine E, would know the recipient machine, that is the machine D's MAC address, right? So it is the source machine and the destination machine is the machine D. And for the source machine E to send a frame to the destination machine D, source machine E should know the destination machine D's MAC address. So in this case, the source machine E must know the destination MAC address of the machine D, which is MD. So now let us go through the steps regarding how the source machine E can know destination machine D's MAC address. So step 1. E wants to send data frame to the destination machine D, whose IP address is 12.1.1.2, right? So E tries to prepare an Ethernet header in order to send a frame to destination machine D. But at this point of time, the machine E do not know the destination MAC address. That is, machine E do not know MD. So next thing that the source machine E does is to look up in its ARP table and check for the entry corresponding to IP address 12.1.1.2. So we assume that the ARP table of host machine E is empty, and therefore E do not find MD, that is the MAC address, opposite to 12.1.1.2 entry in its ARP table. So after step number 3, source machine E knows that it has to make use of ARP protocol in order to know the MAC address of destination machine D. So the next thing that the source machine E does is that it checks whether the destination machine D is in its own subnet or in some distant remote subnet. So these are the 3 steps using which the source machine E can know whether the destination machine D is in local subnet or in remote subnet. So what are these steps? E compute its own network ID, right? So how E can compute its own network ID? Apply the mask value on its IP address. So it will get 12.1.1.0/24. So this is the network ID in which source machine E is present. Next, E applies its own mask value, that is 24, to D's IP address, which is 12.1.1.2, and it gets 12.1.1.0/24, which is same as E's network ID, right? So E concludes that destination machine D is present in its own subnet, right? Now once the source machine E concludes that the destination machine D, to which it is trying to send a frame, is present in the local subnet, therefore source machine E can now launch ARP broadcast request message to know the MAC address corresponding to IP address 12.1.1.2. So in step 5, E now wants to know D's MAC address. E sends out ARP request message on all local interfaces operating in the network ID 12.1.1.0/24. Now in this topology, E has only one interface, which is IFE, and it is operating in the network 12.1.1.0, and therefore E will launch ARP broadcast request message only out of interface IFE. So in step number 6, the host machine E places its frame on the wire. Now let us see in the next slide that what are the various values present in the ARP broadcast request message that is generated by the host machine E. So you can see that this is the ARP broadcast request message which is generated by the host machine E and is placed on the wire in order to know the MAC address of the destination machine D. So again, the ARP broadcast request message end of the day is an Ethernet packet, and therefore it contains an Ethernet header. The destination MAC address is the broadcast address because it is a ARP broadcast request message. This ARP broadcast request message will be received by all other machines present in the same subnet. So note that the destination MAC address of our broadcast request message is a broadcast address. The source MAC address will be the MAC address of an interface on which the R broadcast request message is issued by the source machine. So in this case, the source MAC address will be ME, which is the MAC address of local interface IFE of source machine E. The type field is 806. So 806 is a standardized value which represents that the next header following the Ethernet header is actually ARP header. So this 806 value do not say whether it is ARP broadcast request message or it is ARP reply message. It just says that the next protocol which is encapsulated by this Ethernet header is ARP message. Now coming to the payload part of this Ethernet header, that is, this is payload. Now this payload could be ARP broadcast request message or it can be ARP reply message. Now the distinction between the ARP broadcast request and ARP reply message is done by reading the value of the opcode present in the message format of ARP protocol. So remember, there was the field called opcode. If the value of this field is 1, then it means that this Ethernet frame is carrying ARP broadcast request message, and if this value was 2, then this Ethernet frame was supposed to carry the ARP reply message. I have shown only the important fields which is important and relevant from the point of understanding the functioning of ARP protocol. So the source MAC address that is present in ARP broadcast request message will be the MAC address of the source machine E, and the source IP address will be the IP address of the source machine E, which is 12.1.1.3. Now this is the destination MAC address field which actually E wants to know, and therefore it is filled with all 0 values. So it is this field which actually the source machine E is trying to know, and therefore the source machine E is taking all the pains of issuing our broadcast request message to know the destination MAC address of the destination machine D. And the final field is the destination IP address, which is the IP address of the destination machine D, which is 12.1.1.2. So you can see that this snapshot shows what are the various values present in various fields of ARP broadcast request message. Of course, this ARP broadcast request header is not drawn as per the specification. I have shown only the relevant fields which is important and relevant from the point of understanding the functioning of ARP protocol. So it is this ARP broadcast request message which is finally placed by source machine E on the wire in an attempt to know the destination MAC address of destination machine D.